Hello everyone, we'll be starting in a few minutes, so please bear with us. Okay folks, can anyone please confirm the audio and screen share before we get started? Please confirm if you can see me and hear me clearly. Alhamdulillah. Excuse me. Okay folks, so let's get started. Good morning, good evening, good afternoon. It depends on from you are joining the program. Assalamu alaikum warahmatullah. Welcome to Big Bang Data Science Solutions, the 10-week program, the free programming on NLP with Python. And now we are in week number 3. In week number 1, we talked about the importance of learning data science. We touch base on some great topics. So, like, what is data science? Why do I need to invest in learning data science? What is the day-to-day looks like for day-to-day activities looks like for data scientists? Then in week number 2, we talked about the crash course in Python. We touched base on the 6 most important libraries in Python. Mainly, we talked about NumPy, Pandas, Matplotlib, and of course, we 3 hours is not enough to cover everything. So today we are going to talk about the NLP. What is an NLP? The history of NLP, and we'll talk about the levels of NLP, tasks of NLP, applications of NLP, and of course we are going to have a demo on NLP on the Quran and the Bible with Python. So it's an interesting now demo. So please stay with us. And by the way, please go ahead and share the link on your social media. So please let's get to spread the word and spread the knowledge. So please share the word, and I do really appreciate that. Okay, so that is the deal for this week. It's simply an introduction to NLP. And week number 4, we will dive deep into some of the NLP methods, feature extraction method. Then in week number 5, we will talk about the machine learning for NLP. So we will develop a classifier. Uh, excuse me. Week number 6, we'll talk about how to extract data from the web, what we call web scraping using API. Then in week number 7, we are gonna deep dive into other advanced techniques or advanced methods. So we will learn about topic modeling. Then we will try to build a chatbot later in week number 8. Week number 9 is text generation and summarization. And week number 10, we will learn the sentiment analysis. And of course, we would expand the program into 11 or 12 weeks, depends on how much we need to learn. So that is the plan. For those who we have more than almost 600 students have registered for the class. but almost 200 students have not accepted the invite yet. They have not accepted so almost 262 they have not accepted the invite to join the Canvas yet. So if you have registered for the program and you are not in the Canvas, you are not on the Canvas, so please reach out to me. I will be more than happy to assist you. Rather than that, for those who have access to Canvas, you are gonna have the training materials available in week number 3. Just click on training materials, click on the link, and of course it's going to take you to presentations and the codes. So you are going to see the presentation from today, and also you are going to have access to the codes for today's demo. So that is the deal for today. Okay, folks, so now we are going to jump into a lecture. So it is pretty much a very long lecture. We'll try to cover as much as we can. Of course, we are not going to go through every single slide of this lecture, because this is a lot of information, but I will cover as much as I can, because I really want to spend more time on the demo, which is more excitement or more fun when we play with the codes. So let's get started. Okay, so today we'll be talking about the NLP, the history of NLP, the tasks of NLP, levels of NLP, applications of NLP, NLP pipeline or the process. Then we are going to learn about some of the most common libraries used in NLP. And of course, we are going to have a demo on NLP, on the Quran and the Bible using Python. So what is an NLP? It's simply, when we hear the word NLP, it's simply the natural language, the language that we spoke as a human. So we trying to get this this language either in writing or in speaking, and transform it into digital, manageable text that we can apply scientific methods, statistical analysis, machine learning to get some insight. So NLP is an intersection of several fields. It's simply a combination of computer science, artificial intelligence, and linguistics. In NLP, there are two components, natural language understanding, NLU for short, and natural language generation, NLG. And of course, we are gonna explore these two components later in the presentation. So these are some of the definitions of NLP I found online. So NLP refers to the branch of computer science, and more specifically artificial intelligence, or AI for short, concerned with giving computers the ability to understand text and spoken words. So speech and text in much the same way as a human way a human being can. So simply training a computer, training a system to understand our natural language through either in text format or speech format. So that is the definition of the NLP in a nutshell. Of course, I'm not going to go through all of this in wording, so this is something that you might need to go through once you have access to the presentation. Okay, NLP is applying machine learning models to text and language, teaching machine to understand what is said in spoken and written, means in speech and text. In the focus of natural language processing, whenever and we are all using NLP, either you like it or you don't, especially if you are using smartphones, you use smart devices. They are equipped with NLP systems. So whenever you dictate to your iPhone or Android something that converted to text, that is an NLP in action. So everybody is using NLP, either you know it or you don't. So the NLP is part of our lives, especially since we are in the involved in the social media, using the smart devices. So NLP can be used to cross-sell, upsell, to improve the quality of the services, improve the quality of products that we provide to our clients. One way to do it is simply gather review data and analyze it on the fly and make a prediction or make an action, take a necessarily action right on the fly. Okay, so history of NLP. There are three phases as far as the history is concerned. The first phase is 1950 to 50s to 80s. It's a linguistic method and handwritten rules. There is no algorithm at the time, so we are basically in the early stage of NLP. And the second phase is 90s to now. So they developed Corpus, which is digital collection of documents using statistical method, scientific method. And now we are now to a future. We don't know when. We don't know what's coming next. They are using deep learning, which goes through not only sentences or words, but through the characters of a word. So that is the history of the NLP in a nutshell. So in the from 1950s to 1980s, there were some rules. So we have the rules from the linguistic standpoint. We designed rules and sentence structures, parsing, etc. Then for the handwritten rules, is simply we had some rules in the format of FLs, FDs, and do this, if that, do that. And but the problem with that methods, it's too complex to maintain. Of course, you are gonna need couple of hundred of line of codes to the very small things, and it cannot scale. So you can design a system that runs for a small data set, but when you apply the rules on a large data set, it fails, and it does not generalize. Means once you apply it on unknown data, it is not going to work. It does not work on unknown data. So once you apply these rules on a sentence that like for example, I love to go to school, you apply it, you learn a rule from this sentence, but when you apply the same rule on a sentence like I like to go play soccer, for example, it fails. It does not generalize well. That is some of the drawbacks of the linguistic rules system. Then after now from the 80s to now, so there were a lot of corpus design. Corpus is a collection of documents, digitized documents, searchable documents. So you can we have the ability now to search through sentences, words, and extract the information. And with that search, we were able to apply some machine learning, supervised learning, and unsupervised learning. But the limitation of this period is simply we were limited to the word. We didn't have a chance to go through the characters of the word, and that is what the deep learning is doing. Now, deep learning, it goes beyond searchable words to searchable characters. It loops through the words and it split the words into small pieces, characters, and based on that, it does simply do the job. So the deep learning is overperforming the machine learning. So this is now 26% versus 16%. So deep learning, or I'm sorry, NLP is, as I said, is part of our lives, and the reason why it is so important to invest learn in NLP is now because more than 90%, more than 90% of the data being generated and circulated worldwide now is in the structured format. Unstructured format means it's in a format that is not tabular. It does not have rows and columns, and so there is a lot of data being generated that is unstructured. It could be in text format, it could be in images, it could be audio, video, but it's 90%. Imagine that how large this number is. So, and most of the algorithms, scientific methods, statistical modeling, they've been designed around the 10%. Now they've been designed, this 10% is a tabular, where you have rows and columns. So you have rows and columns. So and the methods, they're working pretty much well, pretty well. And the tabular data sets, tabular data, data with the tabular format, but it fails, in recognizing the non-structured or unstructured data. So, the NLP is simply, when we are talking about NLP for text, not NLP for speech, is simply taking a text. And of course, text here is a raw data. It has a lot of garbage in it. It's not useful. So we take in the text, and of course we post-process and pre-process. Post-process is taking out or fixing the quality of this data, and pre-process is transform it into tabular format, into matrix. So then extract attributes from this text. Then select attributes, because when you transform a text into from unstructured format to structured format, of course you are going to end up having high dimensional data, and the less dimensional data, the better the performance, or the better the analysis. If you have high dimensional data set, of course you are going to require a huge amount of resources in terms of the capacity, feasibility, and the computation, memory, etc. So we need to reduce the dimensionality, and one way, and of course during the dimensionality reduction process, we need to keep only features that would add something to the analysis. So after we select attributes that we are going to need, then we are going to do some data mining in terms of applying descriptive analytics, predictive analytics, could be supervised learning, unsupervised learning, applying some scientific methods, statistical analysis, data visualization, trying to get insight, to get information needed to make a better decision. And of course, at the end, we are going to learn what we call wisdom. So we are going to learn something that would help the management or the business make a better decisions. So this is the roadmap. This is the flow of transforming a text, which is a raw data, into a wisdom. So NLP can be used in many applications. We could use NLP to for product, to gain some product insight or service insight by simply reviewing the feedback, of the clients on a fly, right on a fly. So we through learning what features are most liked, what features are most hated, and we can use the information to fix or to take an action accordingly, fix the service right end of life, fix the product right end of life. So we could use NLP to help us monitor, extract information from news articles and reports, to secure our nations. We could use NLP to extract patterns from given data sets like telephones, numbers, email addresses. And we could use the NLP for document clustering, cluster documents either A or B, either black or white, and based on some similarities and dissimilarities, of course using some distance matrix like Euclidean distance. So again, NLP, as I said, is everywhere. This is some examples, some applications where NLP has been dominating. So NLP is used in filtering, emails filtering, and auto detecting spams of mails. It's if you are using Google, probably you are using using NLP. Either you like it or you don't. Either you know it or you don't. So we could use NLP in speech recognition, especially in the translation. Now you say something in English, and definitely there are many ways to transform it or translate it into whatever language that you want. So use NLP in sentiment analysis, understanding your feelings, your behaviors towards a product, towards a service, and of course take an action accordingly. And we could use NLP to suggest for basket analysis, for recommender systems, for other marketing needs, and for other business needs in terms of cross-selling and upselling. So this is not an exhausted list of what NLP is doing and how we can benefit from the NLP. But in general, NLP could be used for text summarization, topic modeling, text generation, sentiment analysis, compliance and risk management, entity extraction, scientific data generation, intelligence chatbot. Luckily, we are going to do most of this. We are going to learn how to summarize text. We are going to learn topic modeling, text generation, etc. So we are going to do most of this in the coming weeks. But as I said, this is not an exhausted list of what NLP could do for us. Once, of course, we master the process, we master the techniques, and we learn, so we acquire the skills needed to excel in the discipline. Okay, in NLP level, there are 5 levels of NLP: lexical analysis, syntactic analysis, semantic analysis, discourse integration, and pragmatic analysis. So lexical analysis is simply identifying and analyzing the word structure within the sentence. Is simply taking a chunk of a text and splitting that into paragraphs, and even to sentences, and even to a word. So simply understanding how the words are structured within a sentence, within a paragraph. That is lexical analysis. This is the first level of NLP. The second level of NLP is what we call parsing, is analyzing the sentence in terms of grammar, rearranging to determine how the words are connected, how the words are related to one another. So for example, with syntactic analysis, it is gonna reject a sentence in the format of the apple eats the girl. It's the way around. This is a correct English sentence, but grammatically, it's not a correct sentence. So semantic analysis is trying to find the true meaning of a word within a sentence, within a paragraph. It maps the structure and objects of in the task domain to check if the words has meaning. That is the semantic analysis. The discourse integration is simply take a word or a sentence and try to guess the meaning of the current sentence using the previous sentence. And pragmatic analysis is analyzing a sentence is a method of analyzing a sentence to determine if the true meaning of a sentence. It tries to retrieve aspect of the language that requires knowledge of the real scenario or the real world. So these are the NLP levels, and we are going to, of course, learn some of them through this program. Okay, NLP component. There are two components of NLP. NLU, and NLG. NLU, it stands for Natural Language Understanding, and it's simple. It derives the meanings from NLP, and so it maps the language into a space. So, for example, we have a text, and after we analyze the text, we transform that into a space, so where we see the true relationships between the words using some distance matrix. So you are going to see genders, they are close to one another, like for example woman closer to man distance wise, sister close to brother distance wise, and closer to uncle, etc. That is an NLU or natural language understanding. NLG is the opposite, is more advanced, is mapping from computer representing space to a language space. Is the opposite of NLU. Both of them, they work together, and NLU deals with the text, so transforming a text into a concept space, and NLG is dealing more with speech recognition than text analysis. Okay, see example of NLU, example of applications used in NLU: document classification. It's example classifying email as a spam versus not a spam. Example, classify movie review as positive or negative. Classify legal documents as relevant or not relevant to a topic. So very simple, not advanced. As you see, we don't need to design complicated systems to do any classifications once we got the data into a sparsity matrix. So that is one example of NLU, or a natural language understanding. Yeah, so another example, document recommendation. Simply show most relevant web pages. So if you are searching for documents, of course, we have cookies everywhere. So the system remembers what you search for, and it is going to recommend some web pages based on your personal behavior, based on what the system learns about you through your your history. So this NLU would recommend a news article based on the past article that you liked. You say that you like politics, of course it's going to recommend some politics articles. You like sports, you watched a video on YouTube about soccer, of course it is going to remember that, and it is going to recommend more videos on or video clips on soccer. So recommend a restaurant, of course based on Yelp review, etc. So very basics things. So NLU is not more advanced than NLG that we are going to see later. So topic modeling is an NLP application. So example, see how relevant a certain topic covered in a magazine changed over time. So and of course we are going to have a very good topic modeling later in the program. We're trying to see how the politics been changed in US for the last 100 years. Over 100 years, we have all the data sets available, and we'll apply topic modeling on many data sets been available to determine if there is any change. For example, how is the word democracy has been changed for the last 100 years in US, women's rights, how is it been developed, or is there any change over the 100 years, etc. So there are some examples we are gonna cover in the topic modeling later. Natural language generation, or NLG, is it's more advanced. Now we are talking about image captioning, text summarization, machine translation, questions answering chatbot. And this is more advanced. This is not only simple classification or recommendation or a topic modeling. It requires complicated advanced systems to do image captioning, to do text summarization, translation. It requires a lot of heavy models, algorithms to do that. So some examples here about NLG is image captioning. So you have an image, and you design an algorithm that look into the image and gives it a title. Of course, we train a model on millions of labeled images, and the algorithm is going to remember some of the it's going to remember the labeling, it's going to remember the characteristic of, or the functions, the features of an image, and it does compare those features to a new feature or a new image, and based on similarities, it would simply suggest a caption or a title. So it's more advanced, and if we have time, we are going to do some of the image captioning later. And machine translations. So we have over 6,000 human languages worldwide, and as far as I know, a human is now superhero when translating a language to a different language. Like for example, English to Spanish. The yellow part is human, and there are two algorithms that have been developed by Google, GNMT, or Neutral Machine Translation System, and the other one is phase-based machine translation. So we are comparing the two models with the human. For some languages, we are almost at the same level with the model, and I'm expecting the model to overcome or to overperform the human method of translating from one language to a different language. So in the French to English, we almost the GNMT model is almost at the same level as a human model. So this is an example of such translation. So we got sentence, I don't speak Chinese, if this is Chinese, and this is a translation using phase-based method, and this is a method. This is translation using the GNMT method, and this is translation using a human method. You could do the same for Arabic, that we said that I speak better, or English to French, or French to English. But as I said, when it comes to machine translation, we are very close. We design systems that are very close to the human way of translating a language translating language to a different language. So also NLG can be used for text summarization. It's simply you got a paragraph, especially if you have books. You have books, you have many paragraphs, articles, and you really don't have time to go through them. You are going to require a lot of time, a lot of effort to go through each article, every article that you are interested on, or every book, or every chapters, or every documents. So we could use text summarization to summarize the entire article in few sentences. So for example, this is a sentence. Metro Goldwyn Mayer reported a third quarter net loss of $16 million due to mainly due to the effect of accounting rules adopted this year. And this is an example of summarization. Management reports 60 million net loss on a higher revenue. It's very simple, but of course it could be advanced by tweaking the model parameters. So now we move into the NLP pipeline. This is the process. This is what we need to know for an effective, successful NLP processing or NLP process. So the first thing we do is, number one, create some corpus where we transform whatever data that we have into digital searchable format, and of course that is the first step. And once we have a searchable format, of course we are gonna digitize them. Standardize, and of course we are gonna take that data that has been already in a corpus, and there are two parts of dealing with raw data or text analysis. So the pre-processing, post-processing, post-processing and pre-processing. So in the pre-processing is simply dealing with the quality of the raw data. So we need to tokenize. So we need to transform the data to a words. We need to split whatever data that was given to us into either sentences or words. And once we transform the entire data set into a words, it's called tokenization. So we are going to have tokens or words, searchable words, searchable tokenization tokens that we can search through a loop through. Of course, when we search, it's a searchable. We can compare these words with stop words. Stop words means simply most common words that we don't need to include in the analysis. They wouldn't add any value. They are most common words like the, a, for, how, where, when. These are the most common words that you hear, that you use every day. We really don't need these words in the analysis. They could be the most frequent, so we need to remove them. So they are called stop words. And after that, of course, we have some. You might end up having many words with the same root, but different prefixes, suffixes. So we need to remove that and keep only the root of the word. And finally, we need to normalize them. So once we have a final pre-processed raw data, then of course we need to transform it into a tabular format using TF-IDF, feature vectorization, and of course there are other methods that we could use to transform a text into sparsity matrix, into zeros and ones, into a tabular format that we can use later for any supervised learning or unsupervised learning techniques. So this is the flow, and today we are going to learn how we can do this, how to do this with a real scenario. Okay. Yes. So in another method, we tokenize. It starts with tokenization. Tokenize is simply split a text into a piece tokens and to remove punctuations. Of course, we are going to need to move punctuations. We are going to remove the stop words. We are going to remove spaces. We are going to transform all our uppercase to lowercase because like mo midwani with uppercase m is different, is totally different word compared to mo midwani with lowercase m. So we want to lowercase everything to avoid duplicates. And after that, we are going to remove stop words like the, a, for, when, where, etc. Then after removing stop words, that we need to stem and limatize. Stemming is finding a root of the word and keep it, and limatize is correcting the spelling of the word. Then post-tagging, so we need to understand what type of words that we have. Are they verbs, nouns, etc.? And after that, then we extract information from the text that we can use for a decision making. Okay, so this is an example of tokenization. So we got a sentence, hello world. This is a sentence. This is a sentence tokenizing. And by the way, this is an NLTK method. And NLTK is one of the libraries, most common libraries used in NLP. So so in tokenization, we have sentence tokenization and we have word tokenization. Now, sentence tokenization is splitting a paragraph into sentences. So we get sentence 1, sentence 2, and word tokenization is splitting a sentence into words. Hello, one, world, exclamation mark, this is, and even it considers space, considers punctuations as a word. But later we are going to remove this, we are going to remove the punctuations, we are going to remove the stop words, special characters, and we are going to keep only the most common, or we are going to keep only the valuable things, or the valuable words. So that is tokenization. And n-gram is another concept. So in the process of understanding how the words are structured, so we want to know how many words, what is the structure of 2 words when they are together, what is the structure of 3 words, 4 words. It's an n. N stands for a number, and grams it stands for words. So this is n1. So we have a sentence. This is a sentence, and if you were to split it into n-gram, n equal 1. So this is a sentence. So this is a unigram. Bigrams is 2. So now we got this is 2, is a 2, a sentence. So trigram and 4 gram, 5 grams, it goes that way. So 3 gram, trigrams is this is a sentence. And so the n-gram helps to understand the structure of a words within the sentence. Stop words are simply the most common words that we use in our daily life. So, like for example, about, above, after, again, against, and, all, and, any, etc. We have, I believe we have, if I'm not mistaken, is 2018 stop words in English. We'll find out. I don't remember, but I think it's 2018. But we'll double check. So of course we want to remove all these stop words from our documents, from our corpus. Why is that? Because these stop words wouldn't add any value whatsoever to your analysis. It could be the most frequent, and of course they are gonna distort your statistics, and they are gonna derive you from the reality. So to remove these stop words, so the first thing we gotta do is we need to split a sentence into a words. So then we are gonna look through We are going to loop through, we are going to compare those words or those tokens to the stop words. So if a word is equal to any word, if a word from the documents that we are analyzing is similar to a word from this stop words list, we are going to eliminate. So for example, we have an apple a day keeps diseases at the bay. So when we remove the stop words, N is gone, A is gone, A is gone, and at is gone. So we got apple day keeps diseases bay, and we got the punctuation, which we can remove later. So these are called stop words, and I believe the NLTK supports couple of languages, 10 languages, including Arabic. So if you are interested in NLP in Arabic, yeah, we got the covered in terms of stop words. Some other languages, they are not supported yet. Okay, then stemming. Stemming is simply keeping the root of a word. So for example, helps. Yeah, so we are going to remove S. Helping, we are going to remove ing. Helped, ed. Helper, ar. So we are going to keep only the word help. Otherwise, the computer or the system is going to recognize 1, 2, 3, 4, 5 different words, which would cause a lot of problems to the analysis. So to avoid such a problem, so we are going to stem a word, or simply keep the base or the root. That is stemming, and sometimes stemming is very fast, but it creates a lot of problems in terms of in terms of the meaning of the word. So sometimes it creates a word that does not have any meaning through removing the affixes of the word. So there are three methods of stemming: Poster stemmer, Lancaster stemmer, and Snowball stemmer. And one of them, they are doing the same job. You don't need to use all these three methods. You use only the method that you want. You could try. I used the Lancaster many times, but you don't have to use all of them. Use only one. Limbatization works similar to the stemming. It simply looks for the word, the root of the word, by applying some morphological analysis, and it does use a vocabulary list. So once a word is transformed to its root, it compares it to an online dictionary called WordNet, and of course it applies some machine learning algorithms, k-nearest neighbor, to determine which word out of the dictionary is closer to the word that we just limitize. So when you limitize, you might end up having a word which does not have any meaning. So we want to determine the meaning of a word. We want to fix correct the word, spelling of the word, by comparing that word to the WordNet, to the online dictionary database. Then post-tag, of course, once we have a text, we want to know what type of words that we have. We could tag. It's called post-tagging. We could tag the words in terms of identifying if they are nouns, verbs, article, adjectives, etc. This would help us, the NLP, help the system to understand the structure of the word, understand the meaning of the word, and act accordingly. So we have a text. And now we want to tag it, post tag it. So text is NLP, mining is noun. Then we got here a comma is comma. Also is RB, referred is a verb. In BBD, text is GG, JJ, data is noun, mining is noun, etc. So it does looks for every single word and determine its tagging. And this post tagging will help us in the second topic, which is NAR, or named entity recognition. So it looks through the words and determine what is the meaning of what the word signifies, what the information carries in the word. So it could be a word referencing allocation, LOC, or percentage, or geographical area, or percentage, or organization, Microsoft, IBM organization, a date, etc. That is called named entity recognition. And of course, we are going to learn this today. So we got here a sentence, a document. Google is an American multinational technology company that specializes in related services and products. So Google is a company. American Google GPE. I think geographical area. Larry Page is a person. Sergey Brin is a person. Stanford University is an organization. And California is an area, is a geographical area. So it does apply. It goes through documents, which could be thousands of sentences. It could be paragraphs. It could be many words, and you go through it very quick and recognize them. Apply some name, recognize the entity, and name the entity, and recognize the name of the entity. So once then finally, after we clean our data through removing stop words, removing the tokenizing documents first, so we can loop through them. So using then we apply some preprocessing steps, like removing the stop words, the punctuations, then removing the white spaces, removing the numbers. Then now we need to transform the remaining data into matrix, into a tabular format. There are many methods. Some we will learn some of them in the program. So many methods like bag of words, TF-IDF, word embedding, or the document matrix. So this is document matrix. And now we have a tabular format with zeros and ones, and we have numbers to represent documents. So this is what we are going to use finally for the scientific method. For the modeling, so we are going to use the tabular format. So whatever method you are going to get, we are going to use, you are going to end up having a matrix. You are going to have a table with the rows and columns, and that is what we are going to need for the analysis. Okay, so the most common method is TF-IDF. TF stands for the term frequency inverse document frequency. TF stands for term frequency. IDF, inverse document frequency, is simply a statistical measurement that does measure how important a word is to a document and a collection. So you got documents, you got this document, how important the specialized is to the entire documents, how important Google is, how important Brain is, how important computing is. So we are going to simply select the most important words and transform them into a matrix, into zeros and ones. Okay, so in regards to tools that have been used for the NLP, there are many tools, many libraries. So the most common one is NLT, Natural Language Toolkit, NLTK. So this is the most common one, and this is what we are going to use today. It's a powerful library which includes classification, parsing, tagging, semantic analysis, tokenization, and is developed by Stephen Bird and Edward Loper at the Pennsylvania University. And another great package is TextBlob. Is very easy. It's easier compared to Natural Language Toolkit, which is more complicated. This one, with a few lines, you could do exactly what you could achieve using NLTK. So we are going to learn in TextBlob in a class later. Core NLP, this is a library. This is a Java-based library, and this is a Stanford University product. It's a it's used for NLP also. It's used for tokenization, classification, semantic analysis, etc. Now, Spicy or Spicy, depends on how you pronounce it. This is another great library, and we are going to learn this. GenSum is used for a more advanced library, used for modeling, used for topic modeling. Now, Polyglot is another library. Now, Pineapple, QPy, and Flare. We are going to use Flare again. And Scikit-learn, Pattern, and Vocabulary. These are the most common toolkits used in NLP. But the most important ones, or the one that I would recommend you guys and investing time-wise, effort-wise to learn, is NLTK number 1, and number 2, and number 3, number 4, and of course I would recommend number 5 as Flare. So learning others is not going to kill you. It's actually it's going to add a lot of arsenals, a lot of tools to your arsenals. Okay, NLP is challenging. Why is challenging? Because language is dynamic. There's a lot of irregularities, a lot of homonyms, homophones, sarcasm, idioms, metaphors, grammar, which now every day we have new words, and it's hard for us as a human to keep up with the evolving the language. Then how about the computers? And these irregularities creates the ambiguities, so it's really hard to understand the true meaning of a word using NLP. These are some of the challenges of the NLP, and that is the end of the presentation. So if you have questions, please go ahead and post your question on the chat. I will be more than happy to address them. In the meantime, please go ahead and share the link on your network. Let's share the word, and let's share the knowledge. Okay, so we are done with presentation. Now we are going to do a demo. It's a very quick demo, and we should be done in less than 30 minutes. Okay, so we have some text here. We have the Quran, we have the Bible, and of course this is not a religious topic. I really don't care about what you believe and how you believe. I don't care about it. So we are not trying to favor a book or a book. That is not the topic of tonight. So we're simply trying to analyze the two books. So we got a Bible, King James Bible, and this is Gutenberg ebook or Gutenberg project. So we got all documents, all the Bible in one file, and we are going to compare it with the translation of the Quran, and this translation is Talal Ithani. Translator is Talal Ithani. So we got Al-Fatiha, then we got Al-Baqarah or Baqarah, and here we go. Then we got all the surahs, all the verses, and this is not the Quran. This is a translation of the meaning of the Quran. So if you have a position, if you have probably you might have an opinion of not being, we should not do this. I totally accept that. I totally understand. But this is not the Quran. This is a translation of the meaning of the Quran. So we want to go through these documents very quick. And of course, the first thing we gotta do is simply trying to, we need to pre-process this data. So we are gonna take this text, number one. Number two, of course, we need to remove the numbers. We need to remove the punctuations. We need to remove the special characters. We need to remove stop words like but, as, for, who, and, our, are, the, this is all stop words. We wouldn't have any value whatsoever. And remove numbers. And when we remove stop words, of course there is going to be a space. So that space is called white space. So we need to remove those white space also. Otherwise, the white space would be the most common words, words in your documents, and that wouldn't give us any clue of what we are trying to analyze. Okay, those who have access to the file, it's an introduction to NLP. So I'm gonna fire it using the, I'm gonna simply open up Jupyter Notebook. So Anaconda prompt. So you're able, if you were here, if you joined the last week's session, you should be able to. You should have installed the Anaconda. If not, and if you need help, please reach out to us. I will be more than happy to conduct a one-to-one session to help you with this. So I'm gonna do Jupyter Pytr notebook. So we are gonna fire the notebook. Okay, so this is my notebook, and I'm not gonna teach you notebook today. I will simply go through the documents, and I'm gonna grab this file, Introduction to NLP, and that is in desktop, natural language processing, and NLP, and week number 3, codes, and this is the documents we are gonna use today. So I'll give it a minute to fire up, and here we go. So of course, if you are running this for the first time, you need to install some of the packages into the system. So the text search, the contractions, and inflict, some of the packages we are gonna need. But since I ran it already, I'm gonna cancel them out, and I'm gonna run. And of course, we are gonna need many libraries to complete the task. Okay, so we are going to import NumPy for numerical Python, Pandas for data manipulation. Of course, we are going to import some libraries, codecs to read the data, string, Unicode data collections, NLTK. This is the package that we are going to use. So today we are going to learn NLP with this natural language toolkit NLTK. It's a huge library, so we are going to import that. I already installed it. If not, then you might need to install it using, of course, the exclamation mark and pip install NLTK. So if you have not installed yet, you might need to do so. Otherwise, you are gonna it's gonna yell at you. Okay. And we don't need the beautiful soup for extraction at this point of time. We are going to need word tokenization, sentence tokenization, tokenizer. We are going to need the stop words. We are going to need the stemming. So this is the 3 stemming methods. Of course, we don't need all of them. and of course we need also the word punctuation tokenizer. So these are some of the common libraries and methods that we are going to need to complete today's task. Yeah, I'm not gonna design the codes from scratch. We already have them built, tested. They are ran successfully. I don't have to invent the wheel. So the first thing we gotta do here is we are gonna create a variable called Quran, and we are gonna read into it the Holy Quran text. Yeah, we are gonna read this file, Holy Quran, first, and of course we are gonna look into we are gonna print the number of words that we have in that text. So I'm gonna run it. So it does print out the first 1200 elements, or let's do the first 200. So these are the first 200, and this Quran has 81,600 no 81,693. This is the number of words that we have in the Holy Quran. And we are going to create another variable called Bible, and we are going to read the Bible to it, and we are going to print the first 200, and of course we are going to print the length, how many words that we have in this text. And we got 44 it's 44 million 5,200 76. So it's almost 3 times I would say 3 times the size of the Quran. Okay, so one of the first thing that I do is simply trying to visualize what the most common words or the most frequent words that we have in these two holy books, the Quran and the Bible. So we are going to use a word cloud image, word cloud method to visualize the most common words used in these two documents. So we are going to use the Matplotlib. Matplotlib is the library, Python library used for data visualization. So on the top of Matplotlib, we are going to use the word cloud. And of course, we are going to generate a word cloud of the Quran, Quran variable. And so the word cloud, what it does is simply visualize the important word using their frequency. So let's run this and cross the fingers. So word cloud is not recognized, so we might need to install that at the beginning. So I'll give you a minute. Install. So I got this misspelled. Install. Here we go. So I'm gonna cancel it out or comment it out. And now if I run this word cloud generation, of course it should work. Here we go, it's working. Now it's doing a lot of math. And here we go. So let's do simply resize this. We are going to do 10, 10, 10. Here we go. So these are the most common words in the Quran, in the translation of the Quran. As you see here, we have God, Lord, will, day, messenger, come, sent, and of course we have some stop words. We don't need a come, we don't need sent. Made, we don't need it. Among, we don't need it. Whoever, nothing. Probably say. These are some common words. Said. So said and say, they are the same root. the same word, the same root, different tenses, but the same word. So why do we need to have two? So we could keep only the root, that is say. So we need to transform said to say, so we can have a higher frequency instead of having two different frequencies for the same word with different writing. So, and we got two gods here. And we got God. I don't know what's the difference. We should have only one. So maybe there is a space in there, or there is an apostrophe, or there is something that makes it unique compared to this, higher frequent word God. So these are the most common words in the Quran. So it gives us a sense of what to expect or what to deal with, and of course it does give us a clear picture of what is most frequent words in the Quran. And we can zoom in and zoom out. So if we want to zoom in, is simply we change the parameters. So it's the same things, but now we are gonna zoom in a little bit. So now we got a zoomed in better image, and we are gonna have the same most frequent words, but now we are gonna have more words. So we got said again, a day, come, thing, leave, let, among, way, sent. But apart from that, we have some words: said, God, believe, Lord, will, people, they. So and merciful. Again, we are gonna have a better frequency, a better list of words once we pre-process this given literature, or this given data set. We can zoom in again, zoom in too deeply again, and here we go. So now we simply by changing the size, the max font, you keep zooming to get a clear image of what is most frequent. So these are the most frequent word of the Quran, of the translation of the Quran, of the meaning, translation of the meaning of the Quran. This is not the Quran, it's a translation of the meaning. Okay, and we are going to do the same, but for the Bible, we are going to do the same. It's simply copy the codes and paste the codes, and change the variable, change the text. And King James version, it's using an old language. So you are going to see some words, common words, but they are in old ancient English. So until, upon, these are all the common words. We need to remove this. We need to let, upon. But apart from that, Israel, Lord, God, Son, this is a stop word, king, will, children. They are the most common word of the Bible. We are not doing anything fancy, simply looking into the most common words to visualizing the most frequent words of the Bible. We could zoom in further to have another view of these most common words. Again, we got a lot of common words, a lot of stop words, but this is an ancient English. Simply means the stop words that we have, does not support, the stop words that we have does not support the ancient English. So what we could do is we need to update the list by simply adding all the ancient words. So this is the modern English, about, above. You are not going to see anything like the, upon, the and yea, thou. so those common words, ancient common words. You are not going to see shalt, thou, behold, thou, hath. This is the, yea. This is our some of the thy, some of the old ancient words. So we need to update the list of the common words by adding these words. We can do that. Okay, and so now we are we have now a clear image or a clear picture of what is to expect in these two great documents, the Holy Bible and the translation of the meaning of the Holy Quran into English. Okay, so one thing that we are gonna do is we are gonna build some package, some functions to do few things for us. So the first thing we gotta do here is we are gonna build a function that takes care of contractions. Like for example, if you have a word with an apostrophe, like lords, we really need to remove the apostrophe, or ain't, or hasn't, or isn't. So we want to make it is not, like isn't. So we are gonna create a function that takes a word or a text, and it simply replace this is a library contractions, and we are going to apply the contractions and fix contractions on that text. So we are going to create this function, and we are going to apply it on the Quran. So for the Quran, we have we started with 1816,923. That is the number of words that we started with. But after handling the contractions, we could get less, or could get higher number. So let's do that. So we are gonna apply the replace contraction function we just built to the entire documents of the Quran, and we are gonna print the length. So we don't care about 20 displaying the first 20 words, 200 words. So we got 817045 compared to 816923. So we got more words after we remove the after we fix the contractions and things. And we are going to do the same for the Bible. And of course we are going to print the Bible before and after, and we are going to compare. So this is the number of words that we have with the Bible, and now we got 2076 and we got 3031. So we got almost 1,000 extra words of the Bible after we handled the contractions. And since this the documents, they are actually extracted from an online source. So we are afraid that we may have some non-string characters. So we are going to use the regular express to remove all the so it is going to remove the regular express is going to loop through all words, and is going to remove anything that is not a string. It's going to remove special characters, it's going to remove punctuations, it's going to remove also numbers. So let's print out the length of the Quran before and after. So this is before. Then we are going to apply the method, the regular expression method. It loops through every single word and simply keeps the strings, and it's going to remove all the not stop words, all the non-string words. So I'm going to run it. So we got 81. Now we down to 76. Of course, we removed a lot of words that don't make any sense, or it has may have a negative impact to the analysis. We are going to do the same for the Bible. Yeah, we are going to do the same for the Bible. We are going to remove all the features or the words that are not string. So this includes the punctuations, the numbers. If you look into the documents, we have a lot of numbers. Let's look into the document one more time. So we got 2011, 2, we got 10, we got a special character, we got a special character here, we got punctuation, we got 3 stars. This is going to be, and we got a lot of space. We got space again, we got punctuation, we got numbers. So we don't need this into our analysis. So we need to remove them. So one method is a regular express, which is going to be a method that we are going to learn. So we are going to learn this later. So we are going to apply that to the Bible. So we are going to print the length of the Bible before and after we apply the regular express that handles non-string things. And so we got so from 4 to 3. So we lost a lot. I mean, we get rid of a lot of thousands of words, or a couple of thousands of words that wouldn't make any sense or would add any value. So now we are gonna the second step of the process is we need to remove the stop words. But before we do that, let's take a look into stop words. So we are gonna import from NLTK. NLTK is a package. It has many things, that you are gonna need for your NLP projects. So it does come with classification methods, parsing, tagging, sentiment analysis, tokenization, stop words, etc. So there's a lot of things that this NLTK could help with, or handles and could help with. So one of them is the stop words. So we are gonna download from the package stop words, and so we could take a look into the stop words. So we imported the package. Then we are gonna download the list of stop words, and we are gonna need the English stop words. Yeah, we are gonna need the English stop words. Yeah, so it's gonna take a moment. So these are all the English stop words. If you need Arabic, just type in, replace English with Arabic. Then you are gonna see the list of all Arabic stop words. For those who speak Arabic, dalikuma, wa, kada, biyad, ba'd, hati, and for the Arabic stop words, we got 700, almost 700 stop words for the Arabic. For the English, you got 2018. Yeah, we got. I'm sorry. My apologies. 179. I thought it's 2018, but it's 179. So it's almost 3 times. The Arabic words, Arabic stop words, they are almost 3 times the size of the English words. Let's say Spanish. If you are using Spanish documents, and of course you need to download the Spanish, and let's see how many they have. Is 313. Urdu, I don't know if there is an Urdu. There is no Urdu, or I must have spelled. I think it's Urdu. I don't know how to spell the Urdu. My apologies. So anyway, I'm not, no, I'm Arab. I'm not, I don't speak Urdu. So my apologies. Okay, so yeah, let's find out the list of, yeah, this is all the supported languages: Arabic, Azerbaijani, Bengali. Let's take a look into Bengali. I don't think there's Urdu. Yeah, there is no Urdu. That's why it's not, did not give us anything. So let's take a look into Bengali. Here we go. How many words? It's 3998. But Arabic is, of course, Arabic is you know, is an import. You know, is a big. I wouldn't say a big. It's a rich language. It has, you know, one things could have many words. Depends on the situation. So it's a rich, morphologically rich language. So let's do English again. So we are going to use only 179, and this 179, by the way, they are modern English. As you see, it's modern English. Don't doing, each, few, for, from. So we need to extract these words from our documents. Okay, so few things. Also, simply we have downloaded the list of stop words. We have not done anything yet to our documents. Yeah, I don't think Urdu is available, and if you are interested in Urdu, you could using C++ programming language, you could actually create your own stop words if you are doing it on Urdu. Okay, so we are going to create a few functions. One function is to replace the numbers. Sometimes, you know, especially if you are working on, let's say, finance documents where you have to deal with numbers. And if you were to remove all numbers, of course, you end up having nothing. So what we could do is we need to replace the numbers into words. Like, for example, 1, we could write it as ONA. 2, we could write it as etc. So we can we can replace the numbers using the inflect library that we already imported. So using the inflect library does support changing of the words of the numbers, or replacing the numbers. Replacing the numbers with the string, with the words. PDF. Inflict pi. Yeah, this is a library. Let's take a look. Okay, correctly generate plurals. It does more than that. It generates plurals, singular, ordinal, indefinite. Convert numbers to words. This is what we want this library for. Is convert numbers to words. I don't care about different other things, because you really sometimes, as I said, if you are working on documents, it's finance documents, you are gonna have a lot of formulas, a lot of numbers, and if you were to remove those numbers, you end up having nothing. So what we could do is we need to transform to replace the digits and with words, replace the numbers with words, and this library would do the job, and that is what we are going to do. Yeah, we are going to use that library to replace, which it's not going to work anyway. Why is that? Because we already using the regular express RA, we already removed anything that is not string. So we could have run this prior the regular expression method. So if we were to keep the words, but in our case, we really don't care about the numbers because they are simply regular numbers and they are not in the original text. If you have numbers as original, then you might need to consider keeping them by replacing them with words. So we could do this, apply this method prior applying a regular expression that looks into the words and compare them and removes anything that is not a string. So we are going to create a replace number function, simply a function. We have yet to apply it. Then we are going to apply the stem words. We are going to use Lancaster stemmer, and what it does is simply remove the affixes of a word and keep only the base and the root of a word. So we are going to create this function that would do that task for us, and we are going to create another function called Limbatize. It does something similar. It's similar to stemmer, except that it compare the stemmed word or the base word to an online dictionary for a correction. It does correct the spelling of a word once lemmatized. Okay, so we just built some function that we are going to use later for data preprocessing, and we are going to use them. So now we are going to take a look into some of the statistical features. We want to see a list of words, and their frequency. It's similar to the word cloud, except the word cloud is a viz technique, where the other technique is simply grabbing or extracting the words and their frequency. So okay, so let's do that. So to extract a list of words, so number one, we are gonna transform the entire literature, the entire documents of the Quran into lowercase. Why is that? It's because to avoid having different words, the same words with different spelling would create some problems. So Lord with L is totally a different word than lowercase l. So what I have to do is we need to transform everything to lowercase to avoid having such problem. That is what we need to do. So, and also we are going to update, if you look into the stop words, this is the stop words that we have. We are going to add more words to these stop words, and we are going to add said, say, would, as, many, upon. We don't have to do that now. Yeah, let's comment this for now. And the first thing we got to do here is we are going to remove stop words from the Quran. So we are going to print the length of the Quran before and after. Before applying stop words and after the stop words. Let's see how many words we are going to end up having. And of course okay, so we are going to print the number of words that we have and that we left for the Quran text. Then we are going to transform the entire documents of the Quran into lowercase, and we are going to split into words, into tokens, and of course we are going to look through those words, and we are going to compare them with all the words that we have, with 179 words that we have in the English stop words, And if a token is similar to a word in the list of the stop words, we are going to remove it. Otherwise, we are going to keep it. That is what this does. So as you see here, we started with 7 6 7 9 6 9 4 8, and we end up having 5 7 8 and 15. So almost a huge number of words that have been eliminated, simply that wouldn't add any value. Okay, and I'm gonna skip this for now, and we are gonna do the same. We are gonna do the same for Now let's take a look into some of the common words. After, of course, we remove the stop words. So the most common words in the Quran is God, 20,624 frequency. Occurrence, Lord, is 909. Said, say. So we need to update. We need to update the stop words. So we are going to add. We don't need the said, say, us. And we are going to keep everything else. So we are going to remove we are going to update the list with said, say, would, as, my, upon, and among. Let's repeat the process. Okay, and now we reduced. And now let's look into the most frequent words. So we got here we go. We got God, Lord, people, they, believe, earth, one, gods, now, accept. Of course, we have God's aliha in the Quran. There is many many gods with S. So what we could do, we could God and Lord could be the same. So we might need to replace God with Lord, or vice versa, and that is what we are going to do here. So we are going to replace Lord with God. Okay, let's do that. Let me repeat the process. Replace I don't know why it's not taking it. Okay, let's do. I'm going to repeat the process. If it does not take it, then I'm going to simply live with it. It's not for a reason. Frequency, NLTK, token without stop words, token without stop words, Q, Quran. For a reason, it's not, it does not accept the replacement. So simply trying to replace the Lord with God, but it's not taking it. Anyway, these are the most common words in the Quran. God, Lord, people, they, believe, earth, one, gods, now, accept. The most 10. If you want to extract the most 20, change the 10 to 20, and you are going to get a 20. But we are going to simply, we need to remove made, comma, made, comma, count. What else? Give, however, however, yes, comma, however, and of course we need to make this a string. Run it again, update the stop words, remove the stop words, change and try again to change the God with the Lord, and now print out the 20 most frequent word of the Quran. Okay, so let's take a look. So this is the entire Quran in few words, And of course, this is a translation, and a translator has his way to choose a word. Every translation is different than others, and this is not the Quran. This is a meaning translation of the meaning of the Quran. But regardless of the translator opinion or perspective or way of translation, these are the most common words in the Quran. God comes first, Lord, people, they, believe, earth, one, God's, no, except, merciful, good, messenger, away, so we need to remove this away, punishment, heavens, we need to remove give. Actually, give is not a stop word. See, truth, and fear. So these are the most common words in the Quran. So let's do the same for the Bible, and let's visualize this. We could visualize this, and here we go. So God comes first. God is the most frequent word. Allah subhanahu wa ta'ala is the most common words in the Quran. So I don't know, Fatima, if we have questions, but unfortunately I didn't have time to go through the chat, but please feel free to pose your question on YouTube. We will be more than happy to address them later. Okay, the second most common word is Lord. So we might need, they are synonyms, they are mean the same. People, الناس, they, اليوم, believe, آمنة, earth, الأرض, one, واحد, God's آلهة, no, اعرف, except, إلا أو باستثناء, merciful, رحيم, etc. So now we are gonna do the same. Yeah, we are gonna do the same with the Bible. Of course, we are gonna, at this point of time, we are gonna simply keep the same stop words. So we are gonna transform the Bible into lowercase, and we are gonna split the Bible into words, so we can look through those words called tokens and compare them to the list of words given in the stop words. And of course, if there is any similarities, we eliminate the tokens from the Bible. Here we go, and I'm gonna comment this out for the moment. And we are gonna do the same for the Bible. We are gonna print out the number of words before and after. And now we are gonna get rid of many millions of words. We are gonna get rid of millions, thousands of words. I know for sure. But not with what we have in the Bible, because the Bible is used, the King James version of the Bible that we have, it does use old ancient words. So this is what we have end up. But if we were to look into the most frequent, shall, unto, thou, thy, ye, thee, no sense. If we were to look into the most 20 words, most of the frequent words, that wouldn't make any sense. So what we have to do is we need to update the list of the stop words by adding this ancient words, and that is what I'm doing here. So we are going to update the stop words with some special characters and with some words, common ancient words. So let's repeat the process. So we got 30,000, 300, 308, 406. And now let's take a look into the most frequent. Here we go. We got Lord, God, man, Israel, son, king, people, house, one, children, day, land, man, hand, saying. So we are going to remove the saying also. Yeah, we are going to do comma, saying, comma, and behold, behold, therefore, and behold. So we need to add that comma, behold, and I believe has. This is a stop words. This is has not. It has not. Okay. Let's change this into strings, otherwise they are going to yell at us. Run it again. So we are going to run the process again. We got a few more words. Now take a look into the most frequent words. Jesus, sons, things. So now let's compare. Let's compare the two lists. So this is the most common words from the Quran versus the most common words of the Bible. Okay, and of course we have to take into consideration the size of the documents. So Lord and God, they are the first. The Quran, the Lord and God. Man is the second. People here, we got people. We got people there. We got day. There is no day. We got one. And we got one. So we got some. Anyway, we got. No, both of them, they have lot of in common. The Quran and the Bible. We believe, I believe that they are from the same source, no doubt. Regardless of what, regardless of the politics, I'm not going to go through that. But yes, the two great books, they have the same things or the same focus. They are talking about God and the Lord, of course, with few discrepancies or few variant. Now, in the Quran, it talks about people, and in the Bible, it talks about man. Israel, it's not. It's in the Quran, but it's very low frequency. Son, there is no son in the Bible, in the Quran. King, it's not in the I don't think. Yeah, there is a king in the Quran, but it's not most frequent. House, children, a day. I believe got a day here. Man. So we could translate man to people. Then the first most known figure person is David. Is 1,011 times frequently, and Jesus is 983. Okay, so let's visualize that also. Yeah, we are gonna visualize that. And let's take a look into yeah. So we are gonna stop here. And it's almost 3 o'clock. So next week we are gonna continue this exercise. So we are gonna limitize words, and of course we are gonna apply some. We are gonna let's do that very quick. So we are gonna apply the limitize stem and limitize function that we created above. So we are going to apply token ws. So it's token q. Yeah. Okay, applying limbatization through all the is going to print. So this is what it does, limbatization. So you got open, it simply removes the n. It says op al-fatiha name, it removes e. Now we have num, which does not mean anything. Gracious, gracie, merciful, mercy, praise, pra, God, God, Lord, Lord, words, it removes s. So it simply it keeps it search for the root of a word, but it creates a lot of misspelling problems, and that is where the limbatization comes handy, because limbatization, what it does, it compares the word with the actual dictionary and correct the misspelling. And yeah, let's do that very quick, and I promise. Where is the token? Okay. Is not token, q is not defined. Token without q. Yeah, I cannot. I have a lot of misspells. So what is the yes, I think this is the right word. Lowercase, change this. So we want to compare the frequencies of the most common words in both the Bible and the Quran, and we are going to stop. There we go, and we are going to do the same for the Bible. I think it's okay. So we are going to do the same for the Bible. Okay, and now let's we are going to print out the most frequent words again for both. So we are going to replace. Actually, we just ran the functions, and now we are going to apply the remove numbers again for the Quran, limbatize the Quran, and get the text from the Quran. Word patterns is not defined. Yeah, let's find out where did we use this. Yeah, I need to run this. There we go. Now it should work. Here we go. Apply the Bible, and now we are going to use. We are going to create. We are going to compare the two literatures in terms of absolute frequency, relative frequency, and most common words. So we are going to create a data frame. For we are going to create a function to create a data frame with three features for both the Quran and the Bible, and we are going to do the same. Now we are going to yeah, just waiting for. Here we go. So these are the most frequent words with their relative frequency. So God is 2624 and is 0.048. The relative frequency is simply dividing the number of frequency by the number of words that we have in the documents. Lord is 0.01, people is 0.12, day is 0.08, believe is 0.007, one is 0.06, etc. And we need this. We are gonna do the same for the Bible. So this is the Bible, and let's compare the frequency. So the Lord In the Quran is 0.01, and in the Bible is 0.25. God is 0.01. In the Quran is 0.04. So we have more frequency of God in the Quran versus the Bible. Man is 0.01. There is no man in the, but we have people. Yeah, so people in the Bible is 0.07. People in the Quran is 0.12. 1 is 0.06 and 1 is 0.06, almost the same. Al-Ahad. Okay, and now that's it. So we are going to stop here, and we are going to continue learn this exercise next week. Okay, folks, that's it for today. So hopefully, my apologies if I didn't have a chance to address any concern, any question that you might have, but please go ahead and share your concern, share your questions on the YouTube channel. I will be more than happy to address them, either through replying to your chat on YouTube, or get through them next week. Okay, folks, so that's it for today. I'll talk to you later. Bye, everybody. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.